Okay, welcome to the online lecture. This is chapter 20, the second law of thermodynamics. Now just to review, we already know the 0th and first law of thermodynamics. The 0th law is thermal equilibrium, which says anything that are in thermal contact, meaning touching, for a long period of time, will eventually all be the same temperature. Okay, that's the 0th law. The first law says change in thermal energy is going to be equal to work done by the environment plus heat. And you can change the sign of the work if you talk about the work done by the system, and then it just becomes negative, okay? The second law of thermodynamics has to do with entropy, and we'll address it in this chapter. So here's sort of the general direction that we're going. We're going to talk about the direction of thermodynamic processes. So which way does the time arrow point? Then we'll talk about heat engines, which will bring up specific heat engines like heaters, refrigerators, internal combustion engines, and we'll talk about efficiency in terms of those things. And when we talk about efficiency, we'll sort of work on the Carnot cycle, which tells us about the maximum efficiency of things. Then we'll introduce the second law of thermodynamics and explore the concept of entropy. All right, so let's start.
Nekla dloi tatuaris gativ ut nosterov nieszczęsny nurnodzie twe mit mo atrof turin tel ketegel venia figreg nodia Każe ket nastani masimia Dwa katu twaim kiet Nekla batu twaim kiet Ich nie auf Südlabal gehen, ich nie auf Südlagau. Nein, is on me, not some Jack. I don't care if I never get back as me root for home team. If they don't do this, a shame for its own root. They say it's out the old game.
So in that video, which of the processes are reversible and which ones are not? Okay, the reversible ones are anything that don't look weird when you run the video backwards. So at the end part, when he's putting on his clothes, right, that doesn't look weird run forward or backwards. You could do it either way. But when you're popping the balloons or when peanuts are flying back into the box, that's going to look strange, and that is an irreversible process. Peanuts never spontaneously jump into a box when they were all over the floor. And just like that, if you look at these pictures, can you put them in chronological order? This is an irreversible process. And we know, just because we have experience living in the real world, that this order goes B, right? So the things that are over here, this is a very ordered system. Then you go C, this is the energy that you're adding to the system, and then you have A, which is a very disordered system. So we know things only really go from ordered to disordered. You're never going to have a tornado and spontaneously go back to this. Okay, so this is the difference between reversible and irreversible processes. A reversible process is a process that can happen in either direction. So for instance, a collision like this, where you have these particles coming in and interacting, that's considered a reversible process because you can run it the other way and it looks pretty much the same as before, okay? These are both processes that look okay. So before, right? And then after. So you can run this either way and it's going to look exactly the same. Run it forward, run it backwards. That's a reversible process. An irreversible process looks something like that. It can only happen in one direction, okay? Here, before and after are going to be very different. So before, the car is intact. After, the car is all smushed and there's stuff everywhere. You're never going to have a car with stuff everywhere spontaneously do this and go back to being an intact car, okay? It'll take lots of work and it'll never be quite the same. So this is an irreversible process. This is a process that can only go one way. All right, so here's a clicker question that I'd like you guys to think about on your own. Your left and right hands are normally at the same temperature. Is rubbing your hands together to warm them a reversible process, an irreversible process, or there's no way to know? So we'll take a few seconds, pause the video, and think about this before answering, okay? All right, ready? Come back. So it turns out the answer is B. This is an irreversible process, okay? Just like sliding a book across the table, rubbing your hands together uses friction to convert mechanical energy into heat. The impossible reverse process would involve your hands spontaneously getting colder with the released energy forcing your hands to move back and forth. So your hands are never going to spontaneously get colder as the energy released from them getting colder makes your hands rub. That would be really uncomfortable and weird. Okay?